Good morning, everyone, and welcome to Hyper Workshop. This workshop was organized by ETA, which is part of the consortium of Hyper. I'm Marco Dreoni, and I will be your moderator today. So we're gonna have two different parts. So it's gonna be divided in two parts, this event. First, presentations from the Hyper project partners, and afterwards we're gonna have a panel discussion, where you can all ask your questions you may have. Also, if you have one short question after each presentation, that's allowed. And without further ado, I wanted also to introduce to you Dottoressa Silvia Burzagli from Regione Toscana. She's the director of the EU Liaison Office in Brussels from regional government of Tuscany. So please give her an applause.
Yes, so thanks for inviting me, and I have just a short presentation. I don't know if it's in your interest, because I understand it's a very technical and very high level group of people here, but I'll try to be short and focused in explaining you what we are working on just to build a sort of hydrogen valley in Tuscany. So what we have done in the last 4 or 5 years, what we are working on now, and which are the next steps from our side. So, and as Marco was saying, it's a governmental institutional approach that's much more related to define the framework in which the private sector and the academia and the university can work on and just can be in line with the policy view. So, questo qui come funziona? Next. Okay. So just a quick overview on the current programming period of the EU budget, just to see that, okay, we don't have a chapter on hydrogen, you can imagine, but somehow we have some goals and some policy that have already defined which are the priority for the development in the 7 years inside the region, with the cohesion funds that you know that after 2027 will not be more available for region, and this is very worrying for us, but let's see. So we have a sort of almost a 50% of budget that's already allocated on research and innovations, and here hydrogen and other type of research and innovation related can be found here. We have almost, I don't know what happened with the percentage there, but we have another 30% on ecological transition and 10% on sustainable mobility. This is how the funds, European funds, are allocated in the current budget from the regional government of Tuscany. But going fast to the hydrogen sector, we started, I have to say, is not written here in 2020, but after having the COVID pandemic, we had to stop everything, and then we started in hydrogen board in 2022. And it's the main focus was to say, okay, it's a new chapter for us. It's something very new for an institution, but we need to know what's going on in the regions. So we had a call just to collect all the projects that were going on, or imagine, or you know, and coming from all the sector. Okay, research group, universities, institution, not so much, but mainly private sector. And we collected almost 200 projects, but they were in different phases. So some were just ideas or proposals, some were already investment, because we have big players in Tuscany, multinational players that are already investing budget and money in developing hydrogen, especially companies that are already working or already using green hydrogen. So, and the challenge is to put that in a sort of green hydrogen technology. So mobility, it was all these projects I was mentioning, almost 200, are divided in four main group, I can say. Mobility and infrastructures. We have the Port of Livorno, the National Authority of the Port of Livorno, that was already working on that. And research and training, energy and environment. This is the main part of investment from the private sector that is going on. And then also something related to technology transfer to some others part. So the board is increasing the network of people, sitting around. We have gone through 2 years of discussing, exchanging views. It was not very practical, much more on knowing each other, understanding more from our side what was worth to work on at our level, and especially, as I was mentioning, in the logistics part with the Port of Livorno. Then on 2024, we had the Port of Livorno that came in Brussels, just in my office, and that's the part in which we, as a Brussels team, jumped in the hydrogen. You can say, what does it mean? So, but we are not working. It's not only me or my team, but it's just we involved 4 different departments: the energy department, the economic development department, the competitiveness department, and the university and research department of the Tuscany region. So they are all part of the board. Then from 2024, we as Brussels office, because we were focused more in saying, how can the Commission help us in pushing and boosting the implementation of in hydrogen valleys? There were some calls published by the Hydrogen Partnership, the joint undertaking, with some calls, and so we were interested on that. That's the reason why, and we wanted also to see what's going on in other parts of Europe. In the meanwhile, 2023, there was this in the NRRP calls from the Italian government, 500 million national budget allocated for H₂ in industrial zones, and Tuscany received a part of this budget, and 17.5 millions were allocated in one flagship project. We had a call at the regional level. We had many projects, 5 projects, not many. It's a very, advanced technology, so it's still a little bit early. But the biggest one was this flagship project that it was for a hydrogen valley in Rosignano, with Sapio and Solvay Chimica Italia, and this was the total investment that should, come at the end now, at the end of this semester, or maybe just a little bit later. But as you can see, so it was a big focus on chemical industries. And that's one of the hard to abate sectors that we do have in Tuscany. But we have much more. We have many others. We have, for example, the golden sector in Arezzo. They already have a hydrogen pipeline for green hydrogen, and they are also interested in. We have in Lucca the paper industries. So we have some sector in Tuscany that need to be focused. They have the hard to abate energy sectors that need to transfer and to find other type of technologies. And then, as Tuscany, and that's much more in our in our feet, is to work on Interreg project, exchanging best practices, see what's going on in other regions. So we have two projects. One is part of the department I'm part of. That's a Hyperion. That's that's Interreg Europe. And inside this project we have mapped all this industries and others that are working on hydrogen in Tuscany. So we have now a sort of overview and a picture of the situation in our region, and we are now preparing with them next step to become a hydrogen valley. And then we have H2 Move that was run out from the Department of Infrastructures and Mobilities of the region, that is also part of the board. I forgot to tell you. And because, yeah, as you know, logistic is one of the main part where you can apply hydrogen, a big, huge logistic, heavy logistic, not private. But and here in the master plan of the port, again, we are working together just to define the same main goal to be, perceived. And so what is going on now from 2025 until now? We are at the end. Just two more slides, maybe three, no more. We have mapped the H2 chain. Then on that we have selected inside the board a group of partners that can work on writing a business plan for our hydrogen valleys, because we tried, there was a call the second part of 2025. So we tried to push and just prepare a document. We were in contact with the hydrogen partnership, but the part that was missing for us, okay, we had the part related to the research with the universities, we had our main goal, we had the Port Authority, but the problem is more to understand the potential market and the market agreement between the producers of hydrogen and the consumers, and how they want to move and to invest also, because we need big investment also from the private side. We don't have investment at a regional level. We can just take something. We are looking for the next call that will be in 2027, but it's just for a small scale hydrogen valley. Now there has already been a sort of big scales hydrogen valley. So, and with them define a plan. So we ask the private, do you want to put your technician with us? Just make some teamwork and just see how we can, you can put your knowledge, because we are, okay, we know policies, but we are not technicians. So, and you can just tell us more about what your companies can really provide, what is needed from your side, where you can invest, where is worth to invest, where the market can go, and if it's acceptable or not from your side. And so this is a sort of a small, it's not small, but it's just the team that now is working and is, okay, Tuscany as a lead developer inside, with the port of Livorno, because we think that we want to build a hydrogen valley in Tuscany, but starting from the coast and from the port hub of Livorno, because we think that this is very much strategic. The port of Livorno, as I was saying, in 2024 in June, they defined a memorandum of understanding with the port of Damietta in Egypt to import green hydrogen, and involving the Arab Academy and the University of Pisa, just to see how to face the challenges related to transportation of liquid hydrogen. But okay, this can be a sort of something to see for how to import the part, because as you know, here in Italy and in Tuscany we have big problems in having renewable energies that can be used for producing hydrogen, and we know protecting landscape and all the fact that we all know. And so part could be also maybe in a corridor imported, and could be interesting not only for Tuscany but also for Europe or for Italy, but it can be a corridor through the port of Livorno and just going up not to the north. So then we have the University of Pisa and Florence, but it's open also to others, but these are the group of researchers and professors that are mainly working on this type of technologies. And then we have some innovation hubs like the Pond Lab, the technological polo. We have some clusters, Navigo, for example, that's all the mega yacht producers in Tuscany that are interested in experimentation on that. Magona, Cosvig, and here again, Cosvig and Cesta Lab, these are for come si dice? Non mi viene l'energia geothermic energy, sorry, because we have a sort of geothermic base of any energy. And again, it is again near Livorno, so everything is over there. And these are the 9 HD enterprises or companies that are already investing and working in projects related to hydrogen. Solvay, you have already seen, that's the chemical one. Eni, that are doing a sort of bio raffinery here in Tuscany. Then Baker Hughes, that have a test bed to test 100% hydrogen turbines, and Gas and Heat, and after Dumareggi, General Electric, and H₂O₂. So that are all working in the energy sector. They decide to be with us and part of the technical private part of the team. So now they are coordinating themselves among themselves with INEOS, that is doing the coordination, and we have divided them in 4 groups. We are part of all the group with the port, also the university, but the companies have divided some in the just to see how to identify the renewable energy resources in Tuscany, because this is a big challenge, I have to say. Second one, the challenges related to the transition to the production of hydrogen. And then a part is more logistic, so transport and storage of hydrogen, and this is part, as I was saying, Piombino and Livorno. And then the part related to the sustainable market, so the off-takers and industrial, and on the other sides, the part more related to land and maritime mobility or local transportation. And next step, this is my last slides, is next milestones, just to be, I think in transferring the PowerPoint to PDF, there's something happened. So it's not 202G, but it's 2026. So there is now going on a call on PDA Light that to support a pre-feasibility study on a hydrogen regional valley is just launched now. It ends at the end of June. I don't think we will be ready for that. We will try, maybe, but I don't know, question mark. But we know that there will be another call in the second semester. So maybe we will apply to the second semester but we need to have a ready business plan, then to be, supported from the hydrogen partnership, and then, as I was already saying, to apply for next year to the Hydrogen Valley call, and to see what other type of investment we can attract in our region to push on sustainability and transformation in the sense of hydrogen. Okay, I have finished. Thank you for your attention.
Thank you very much, Silvia, for the insightful presentation. If any from the audience have a question to ask to Silvia, otherwise we can move on to the next speaker. Thank you very much again. Now it's my pleasure to welcome on stage project coordinator, who will give us a presentation on the Hyper project in general, so introduction.
Thank you, Marco, for the introduction. What I would like to do is just to give you a very brief overview of the project, to set the stage for the more detailed presentations of the people who've actually done the work. It's been a real pleasure for me to help lead this project, but it's the people who are actually doing the technology development which are the real core and heroes of this project. So the goal of the Hyper project is to develop to TRL6 a modular electrochemical production of hydrogen peroxide with improved efficiency based on the current state of the art. And one of the things that I think is really, really nice about this project is we have these three sectors involved in the downstream application of our technology. How would this TRL6 modular electrochemical plant fit into these three sectors, all of which use significant amounts of hydrogen peroxide? So this is the state of the art. In case you don't know, it's called the athenochrome process. And despite the fact that hydrogen peroxide doesn't have any carbon in it, this is a very carbon intensive process. You start with a steam reforming of methane step to make your hydrogen. So that is a fully fossil carbon process. And then it goes through a number of steps here, which are been optimized to the nth degree in order to make this as efficient as possible. You need a palladium catalyst to do the hydrogenation of this athenochrome intermediate, which acts as a hydrogen carrier in the process. And then it goes through a number of steps. It's essentially the reaction of hydrogen and water to make hydrogen peroxide, but it's a much more complicated than that simple chemical equation. And this is very complicated and has been optimized. You need a cocktail of organic solvents to keep everything in solution. And then it's made in these huge quantities and then shipped. And most of what is shipped is 50%, 45% hydrogen peroxide. So that means you're transporting 50% water all the time, which is terribly inefficient. So what we wanted to do is break this down and do it electrochemically and do it modularly. So the idea when we wrote the project was that we would start with sulfuric acid and do an oxidation of that sulfuric acid to a persulfate. The byproduct of that, or on the cathodic side of the reaction, would be hydrogen, which would be one of the added values you could get from the process. When we wrote the proposal 5 years ago, we were thinking that you could store this persulfate as a chemical energy storage medium. The chemistry goddess does not allow us to do that efficiently. So that is not something we were looking at much anymore. But then the second step of the process is what we call the utilizer, which then takes this persulfate, reacts it with water, and then get the hydrogen peroxide out. So this is electrified, so we can use green electricity to do this transformation. The steps are much simpler. We don't need a catalyst, and we have anticipated hope to get around 75% decrease in greenhouse gas emissions with this process compared to the state of the art. There we go. So this is a Horizon Europe project. You see the budget. Here are the partners and where they're located. 9 countries represented. We're in the last year of the project. So we're coming to the end, but it's been, I think, very, very successful, and we've managed to develop some very nice technology in this process, which we would like to push further. There we go. So what you hear a little bit more about after I'm done are some of these things. In the project we've made cheaper electrodes and more efficient come up with a more efficient electrochemical cell design. That will not be part of the program today. You'll hear from Gregor at JSI in Slovenia about the deployment of our TRL4 mini plant. Andre from Belinka will talk about the deployment of the TRL6 demo, which will be happening later this year. Honk for PDC in the Netherlands, we talk about the process design and techno-economic assessments that we've done. Stavros from Everstang in Luxembourg, we'll talk about the life cycle analysis, and then we'll have one of our downstream integrated processes presented with David from Helios. So thank you very much. You don't want to hear any more from me. You want to hear from the people who actually done the work. So I thank you very much.
Thank you very much, Richard. I actually didn't mention Richard is a chief research scientist at Sintef Norway. And now moving on to the to our partner from Joseph Stefan Institute, Gregor Donancy. Please join me on stage. And he will give us a perspective on how we move to TRL 4 to 5 with our mini plant in Yper. Thank you.
Thank you, Marco. Are you going to change the slides for me? Yeah, okay. So you can go to the first one. So the goal of the project is very clear. The goal is to produce hydrogen peroxide by using only water and green electricity. And if we do so, then we emit a great amount of carbon dioxide that it is released. So the whole process is composed of two major steps, electrolyzer and utilizer. So in the electrolyzer, basically we convert sulfates into persulfate by electricity. And then this persulfate enters the second step, which is called utilizer. And the persulfate there is converted into hydrogen peroxide. Also, sulfate is generated again, and this one is recycled back to the electrolyzer. So it is not a consumable, it is basically a circular chemical that circles around and actually moves this reaction going on. Yeah? In this way, also the whole process is divided into two sub-steps. If you can go further. So the electrolysis is basically one-step procedure, while the utilizer requires more steps for this particular case. So in the first step of the evaporator, we actually increase the concentration of the persulfate by evaporating the excess of water. Then we enter the hydrolyzer, yeah, where the persulfate is converted to the hydrogen peroxide. Then we need to actually separate it from the rest of the chemicals. This is done in stripper, which is driven by steam. Then this resulting low concentration hydrogen peroxide enter vacuum distillation, where we reach the concentration up to target 30% or similar. Next one, please. Basically, this picture shows how the work was distributed. Electrolyzer and utilizer, they actually developed in a parallel way by two core teams. It went from basic engineering down to actually application and testing, but keeping in mind also the integration issues, because both of the components then must be integrated to actually operate as a single device. Next one, please. So this is the case how the electrolyzer was developed. It started by basic engineering. This means studying all the chemistry in the electrolyzer, designing the main components like electrodes, diaphragm, etc. This resulted into an electrolysis cell, which you can see on the middle picture. And then around this cell, the whole system was designed with all the balance of plant components shown at the right side. Next one, please. Here you can see the simplified PID diagram. So there is plenty of balance of plant components, sensors, actuators to keep this system running. Next one, please. This is another picture. Yeah? You can go further. So utilizer was also, the development started by basic engineering. This means that the first step, all steps of the procedure were actually identified. Literature was reviewed. Then all those steps were testing in lab environments. Basically, it was checked if all chemical reactions are going as planned. One important thing is also the development of chemical analytic methods. This was important because it is necessary to measure the presence and the concentration of the components that are actually appearing in the chemical reactions. And when this was completed, you can go next one. We developed this diagram. Yeah, you can see the basic components over here. So this was basically a prerequisite for selecting the components and sizing them. The decision was actually to use glass as much as possible, because by using the glass we omit the compatibility issues with aggressive chemicals. And the other reasons is, if you use glass components, we can easily see what is happening in the device, which is very important for troubleshooting in this, let's say, early stage of development. Next one. So this is one of the earliest 3D models of the entire system. You can see the position of the equipment and components. Next one. This picture shows the system fabricated. It is basically organized in such a way that we have separated chemical and electrical part. Chemical part is on the front side and safely separated from the electricity and the control, which is on the back. Next, please. Yeah. One important part of the entire system is the control, yeah, which must be completely automatic, because we are aiming at TRL6 device able to run by itself without any human intervention. So the basic tool for the automation are so-called state transition diagrams, shown on the picture over here. The idea is that each of the sub-processes is independent, it runs autonomously, and it typically goes from stop state through some preparation steps to the operation, and then to final finished step where the reactions and the procedure are finished. Next one, please. Like any other processes, also this one is equipped with a SCADA system, so there are a number of screens that show the condition of the process, and so all the variables and process state can be monitored by using these screens. Next. The control is implemented in an industrial controller, which controls the complete system, utilizer and electrolyzer. There is a 4-level control. At the lowest level, we have all those input-output signals, communication protocols, and the possibility for manual intervention with the process. One step above is a layer of feedback controllers, like closed-loop PID controls of various variables, plus other function blocks. On the level 3, we have these mentioned state transition diagrams for all sub-processes, and at the top level is then the coordination of all sub-processes to run as an entire unit. Next. So the process was built, it is up and running. Now intensive improvements and modifications are going on to make it completely automatical and to reach the TRL6 status. Next. So one important project result is actually demonstration of this process in the textile industry, Inotex company in Czech Republic. This was done at the end of the year 2025 successfully. So we moved the whole device to the Czech Republic, to the Inotex, install it, run it, and produced hydrogen peroxide, which was then used also in textile process to prove its efficiency. So this is the main result. And now we are aiming at final improvement and modification of the system and installation in chemical industry in Slovenia. So thank you. This is all from my side. If there are questions.
Thank you very much, Professor. If you have any questions to ask.
Yeah, this one is able to produce in, let's say, 3 hours around 1 deciliter of 30% hydrogen peroxide. This one. But one thing to mention is that those 4 process steps that are over there described, yeah, they can run in parallel. So this means that, for instance, when in let's say hydrolysis, one batch is going, the electrolyzer can already prepare the next batch. So the process is semi-batch, yeah? It's a mixture of continuous and batch operation. Some more questions, please? Unfortunately, it's not in kilograms per day. Yeah, we would. Yeah, basically in 3 hours, yeah, we can make one production cycle, which results in about 1 deciliter of 30% hydrogen peroxide. Yeah. Please. Basically, this procedure is based on let's say, processes that have existed also already before. But I think that the electrolyzer, it has some unique solutions, yeah, based on special materials that may be identified as radically new and also are the subjects of protection, for instance. Yeah. Okay.
Just we have a small technical issue because something happened to the next presentation. So if you could all be patient for a minute or two. I emphasize that you know, with respect to the amounts of hydrogen peroxide we're making, this is a TRL 4 to 5 system. So you know, we're not going to be making kilos an hour immediately. But that's the next step. So that should be coming. And I believe in the TRL6 presentation, we'll maybe see a little bit about what our goals are for the TRL6 system. I will comment that the KPIs in the project regarding for sulfate production and hydrogen peroxide production for the TRL 4-5 were met. So we are well on our way. I feel like I'm a rudderless ship at the moment.
Sorry for the interruption. There was a change of plan. We now move to Dr. Anke Vlaming, which is the CTO of PDC Netherlands, and he's gonna he will give us a presentation on the techno-economic assessment of the project. Thank you.
Thank you for the introduction and welcome everyone to this workshop. I'm to talk about the techno-economic assessment from our side. We are from Process Design Center. We are located in Breda in the Netherlands. Can you move to the next slide, please? Our mission is to help industry to become more sustainable in every direction, and this is one of the projects we work on. We do this by using unique tools under the name of Prosyn.ai, and AI already indicates that these are artificial intelligence expert systems that we use to help design and also optimize processes to the most the best KPIs that we can define. We base this on expertise and tools that we built up over 39 years. We have a lot of high educated people to help to make the transition from R&D into industrial designs. Our role in Hyper is on process development, integration and optimization, and the techno-economic assessment, which is the subject of this presentation. Furthermore, we lead Work Package 5, which also includes sustainability aspects, which we hear about, and the safety aspects by Ineris in France. Next, please. So the overall concept we've seen, we have an electrolyzer, utilizer, sulfate and persulfate moving around. We use renewable energy sources, RES, you see at the bottom, And then the hydrogen peroxide is sent to the end user, which is in 3 sectors, as Richard explained: paper, pulp and paper, textile, and chemicals, coatings. Well, the hyper process is basically the same for all, but the capacity is different. And also we need to see in how far we can integrate it with the end user. However, we don't want to take on board the full end user process in our design and evaluation. So we only take the benefits from that. Next slide, please. So this is the concept. We've seen it before. We have the electrolyzer on the left side. The pulsar storage was indeed an idea, can still be done, but it turns out to be quite difficult and not so efficient. And then on the right, we have the utilizer, as just explained. Here it's even in a simpler way. We can produce hydrogen peroxide at several concentrations, from 5 until, say, 50%, depending on what is required. Next. The integration was a specific topic because if you look technically at the system, you could operate the catalyte system separately from the system with the electrolyzer and utilizer, which produce the persulfate. So on the left, you see in design 1 that these loops are separate, and then you can use different kind of catalytes. But we found out that to minimize the loss of sulfate and chemicals, the best way is to integrate it over the cathode to the anode and then to the utilizer and back. So that was the preferred configuration from the techno-economic perspective and also from the life cycle analysis perspective. Next. So we looked at several KPIs, and also the project defined a number of KPIs. The first one was on energy, which of course is one of the targets for the European Commission. We had a benchmark, which is the Electrochemical process, including transportation. And there we came to 20 megajoule per kilogram of pure hydrogen peroxide. And after careful design and heat integration, which you see the pinch curve to the right, the composite curves, we are able to reach the target that we set, which was lower than 20, and now we are at 12.7. For the production cost, we are still working on that because it has a number of elements, not only the capital cost, the operating cost, but also how to incorporate the renewable energy sources and how to do that in different scenarios and in time and in different countries. So the production costs are close to target. They depend on the production capacity, as you can see from the graph. We have not yet included in these graphs any benefits for instance, grid stabilization or other benefits or savings that you could imagine by using renewable energy sources only at the time they are available and electricity is cheap. And now in the last part of the project, we look into these renewable energy scenarios. Next. We also did some sensitivity analysis, and then you see that particularly the capital costs are quite important, especially if you build smaller systems. And then capital is weighing quite heavily. So if you take different depreciation time, you see that the spread is rather big. Also maintenance costs, capital costs are quite important. And followed by electricity and also the selling price of the hydrogen. Next. So we look at end user integration in the pulp and paper in Finland. There's a continuous demand at high capacity, so 25 tons per day. They already have a lot of utilities. They generate a lot of utilities, so we're also looking into integrating that. And then finally, there's even a potential to integrate the sulfate loops because they have that internally as well. In the textile, it's much smaller. The use of peroxide is depending on the batches they do or the operations. And there we think about operating hyper as a small batch unit. In the coatings, chemicals in Slovenia, we see that it's a kind of intermediate demand amount. So yeah, that's not only we have 3 sectors, but also from the perspective of capacity, this is a very interesting mix of user cases. Next, please. Now, if you look into the renewable energy sources, you see that a lot of people talk about the EU mix, but actually that doesn't exist. It's more regional, or as I look to you, Sylvia, or it is more per country. You see, for instance, that in Finland, the energy mix is totally different than it is in Czech Republic. And also the pricing is different over time and also per country. So that is something that we now work on implementing this. Next. So we have different options. Intermittent operation of the electrolyzer and possibly utilizer. The electrolyzer is quite easy. It can be stopped and started and at almost any time. The utilizer is a bit more complex because those are more high temperature operations. You need more time for that. We consider also storage, not only for short disruptions, or for instance day night if you use solar, but also for longer periods, for instance the winter time in Finland when electricity is scarce and expensive. And of course the safety aspects are then also important if you start storing persulfate or peroxide. We also look at the co-product. Will we sell it? Can we use it ourselves in the periods that we don't have electricity? And we can also have alternative solutions in connection with the end user application. Next. I think that's it from my side.
Thank you very much, Ank, for the interesting presentation on the techno-economic assessment. Do you have any question from the audience? Please raise your hand. Okay. Otherwise, we can move on to the carbon assessment, so the life cycle analysis. And please welcome on stage the CTO of Aristeng, Luxembourg, Stavros Theophanidis.
Thank you, Marco, for the nice introduction. I can change if you want. Just proceed. So welcome everybody to this workshop. Nice to see you all. My name is Stavros Theophanidis from Aristeng, Sarl, located in Luxembourg. I will talk about carbon footprint assessment of Hyper process to produce hydrogen peroxide. So a few words about Aristeng. Aristeng is an engineering firm. We are headquartered in Luxembourg, but we have also offices in Greece. We are a technical team comprising of 10 chemical engineers. 60% of our team also holds a PhD. We have expertise in process design at basic engineering level and also life cycle assessment, techno-economics. In this project, we focus on LCA analysis. So we are performing the environmental assessment and we focus at the moment on the calculation of carbon footprint, aiming to identify the polluting drivers at this level. So what is a polluting driver for our Hyper process? And to do that, we also make a scenario analysis. Since Hyper is an electrified process, electricity plays a major role. So we make a sensitivity analysis regarding the impact of electricity. So we vary the source of electricity from 100% grid to 100% renewable electricity. How we do that? We increase the penetration of renewables. And the method that we follow is a cradle to gate method, following the environmental footprint, which is aligned with the ISO standards 14040 series. And the functional unit for our analysis is 1 kilogram of diluted hydrogen peroxide, 35% weight percent in water. So throughout the presentation, when I say functional unit, actually, I refer to that value. And all the background processes beyond Hyper are modeled using the EcoEvent database. The boundary limits for our analysis are perfectly aligned with a TEA, so LCA and techno-economics follow the same boundary limits to give the proper message to the audience. So we start with the blue box, which is the Hyper process, comprising of different process steps, and then we also model the interaction with the technosphere. Basically, we model the raw material that inputs and the electricity or energy input, and also the outputs from our process, which can be, of course, are the products, but also some side streams, and of course the impact that they have in the environment. So we calculated the carbon footprint equal to a value of 0.36 kilogram of CO2 equivalent per fractional unit. And as I said, this is based on grid electricity EU mix due to the volatility of the and the differences of the carbon intensity of the grid in several countries. At this level, we focused on EU mix, but we are planning to take this into account by applying Monte Carlo sensitivity analysis and uncertainty analysis in order to see what is the impact of different location, geographic location, on the carbon intensity of the electricity. But this is to be done in the coming months until the end of the project. At the moment, we focus on the EU mix, which is a valid approach in order to have comparison on the same basis. And we also found, as expected, of course, that when we increase the carbon, when we increase the penetration of renewable electricity, we can decrease the carbon footprint, of hyper process by 90%. So moving from grid to fully renewable, we can decrease the carbon footprint by 90%. The grid, the EU mix grid is, according to the EcoInvent database, includes, of course, some renewables. It's around 40% powered by renewables. And then when we go to fully renewables, we have 90% decrease of carbon footprint. Of course, those numbers doesn't say anything if you don't compare them with the state-of-the-art process, which will come soon. But first, I wanted to show you what is the polluting driver of our process. Of course, is electricity. Even in the scenario where only is powered by grid electricity, or the scenario where we have full renewables penetrated in the electricity source, our polluting driver is electricity. And comparing this with anthraquinone, we have some nice results highlighting the potential of our hyper technology, of our hyper process for hydrogen peroxide production to decrease the carbon intensity by 40%. So you see anthraquinone in the first bar has 0.6 kilograms CO2 equivalent per fractional unit. We can go to 40% less, assuming electricity source by grid, and we can go to 93% assuming fully renewables. And of course, again, the penetration of renewables depends on the geography. What is interesting is if we try to understand what is the polluting driver of anthraquinone and make a nice comparison. So first of all, as I think Richard also mentioned, hydrogen that is needed for anthraquinone comes from methane steam reforming, which is an energy-intensive process. And as you see in the Sankey diagram, 44% of carbon intensity for anthraquinone comes from hydrogen. And then second in the row is the steam that is produced. What if, let's make an assumption, we make anthraquinone green? How? The hydrogen that is required is originating by electrolysis, which is powered by renewables. We have so-called green steam, steam produced by electricity, and more specifically renewable electricity. So everything is powered by renewable electricity. Ideal scenario, yes. But what we want to highlight here is that the carbon intensity of anthraquinone decreases from 0.6 to 0.2, and even in this idealistic scenario, hyper carbon footprint is 5 times lower. So if we want a process that is more environmental friendly, hyper has the potential to be one of these processes. But until now, we take into account that hyper produces only hydrogen peroxide, which is not 100% true, because we also produce hydrogen as a byproduct. So what we did in the next slide, we thought, okay, this hydrogen could be used to produce electricity. Or it can be sold as a byproduct. And then you can get the credit by replacing a fossil-based hydrogen. So we perform the same analysis, comparing always the first bar refers to anthraquinone process. We are comparing with different scenarios. So first bar is anthraquinone, second bar is hyper-process powered by grid electricity without utilizing products, the byproducts. And then when we use hydrogen fuel, we have potential to further decrease the carbon intensity. And then depends on other scenarios. For example, if you you sell hydrogen, you can get credits. Why? Because you replace a fossil-based hydrogen. And these credits result in very small, actually very huge decrease of carbon intensity, going down to 0.04 kilograms CO2 equivalent per functional unit. Or if you apply mass allocation and you calculate your carbon footprint of your process based on mass allocation, simply saying I have three products, hydrogen, oxygen, and hydrogen peroxide on a mass basis, I will apply the mass allocation in order to calculate the carbon footprint that is for the hydrogen peroxide. We can go to 0.33. Overall, we have we achieved to go below anthraquinone process, and depending on the approach or valorization of the byproducts or not, we succeed in 3 to 5 times less carbon footprint than anthraquinone. And all this brings me to the conclusions. So we have a process, electrified process for hydrogen peroxide production, which offers a great flexibility and compatibility with renewables, and this is good. And this can make a more sustainable and adaptable alternative for hydrogen peroxide production. And if we compare with anthraquinone, hyperprocess succeeds in decreasing the carbon intensity by 3 to 5 times. And we identified at this stage the polluting driver is of course electricity for hyper. Thank you. Any question? Thank you.
Thank you, Stavros. Now we move to the industrial application of the project. So it's my pleasure to welcome David Zorko from Helios Resins on stage.
Thank you. Okay, so we are one of the downstream process partners. Today I will present our implementation of electrochemical hydrogen peroxide into coatings production procedures. So Helios Resins is a resin producer in Europe. We make liquid resins, polymers for coatings and composite industry. And our role in Hyper, like I already mentioned, is the use of hydrogen peroxide in our production procedures. The Hyper process is something that is very interesting for us because it is in line with our business strategy. So a lot of our research and development efforts go into our sustainable approach, and we were able to achieve that with Hyper, especially in the use of bio-based raw materials, production of volatile organic compound free resins, so high solid resins, and of course also some partnerships, our new partners and connections with European institutes and other firms. We went into 3 different directions regarding our procedures. The first is epoxidation of double bonds in bio-based oils and fatty acids, which can be used for subsequent acrylation. These types of chemicals can be used for bio-based dispersing agents, for pigments, or UV curable bioreactive resins, which are usually 100%, so VOC free, and
state-of-the-art for wood coatings, 3D print, and other uses. The second part was use of hydrogen peroxide in emulsion polymerization, so for styrene acrylic and acrylic latexes, and as a vessel for wastewater treatment, which is already introduced into our production. The first part, like I already mentioned, this is the laser, okay, perfect, is the epoxidation of double bonds. So we have some bio-based oils which are unsaturated. We have these double bonds. In this concrete case, we have soybean oil. We reacted with hydrogen peroxide with catalysts of formic or acetic acid, with amberlite, which is actually a substitute for sulfuric acid, and of course 35% hydrogen peroxide, which can be commercial or from our hyper process to reduce the carbon footprint, like we already heard. The finished product is these epoxidized soybean or other type of oils, which can be used for pigment wetting, which we already tested also. Compared to commercial samples, we here see a graph of surface tension compared to the titration volume of our pigment wetting, pigment dispersant, and the green line is a commercial sample, and of course we can see the yellow one is still one of the first samples, and with our blue sample batch 34 we were able to come closer to the commercial sample. Development is still in progress, also on other types of oils, but we see some promising results also in this scenario. The second type is, of course, reacting our already epoxidized oil with acrylic acid in the presence of some catalysts and radical scavengers. So the terminal double bonds we implement to the molecule don't react too fast, so we don't have a solid gelated polymer already inside. And these types of resins can be used so for UV coatings, usually for wood, plastics, or other substrates similar, or for 3D print resins. That was more of our core business, and the pigment wetting dispersants were something we did in line of the hyper project. We also did a lot of application results already because it's our third year. We've been very busy. Here is one of the examples. So our coatings department, wood coatings department, did a UV curing transparent base coat, where 50% of the resin composition of the coating itself is from our bio-based resins. So here you can see a lot of our types we tried out. So we have a standard sample, and then we did work on tall oil, which is derived from black liquor, from pulp and paper production, from cardinal, from cashew nut waste products, and linseed oil, and soybean oil. So some food grade oils which are more commercialized are already seen on the market, so we were able to compare it to state-of-the-art projects, but we are trying to make a step forward with non-food related oils and unsaturated molecules. We did a lot of testing, so cross-cut, which means adhesion to the substrate, hardness, resistance to cold liquid, gloss. All of these tests basically gave us a conclusion that all of our 4 different tested samples can be used as a drop-in replacement for wood coatings. The second project we were doing was the use of hydrogen peroxide in emulsion polymerization, like I already mentioned, for acrylic and styrene acrylic latexes. The first step we did was just trying to use hydrogen peroxide as an oxidizing agent for post-polymerization. So after we do the polymerization in our emulsion, we still have some residual monomers left that are too high for our customers. So we induce a post-polymerization step, usually with some sort of initiator. But in this case, we did it with hydrogen peroxide. And we concluded that actually we can use hydrogen peroxide as a post-polymerization step. This is a small step we did in the first year of our project because, yes, we lowered the VOC because when the hydrogen peroxide decomposes, we have a little bit of volatile organic compounds, but the initiator levels are quite small, the percentages are quite small, but we could see it can be done, and we could use it for the second step where we used hydrogen peroxide as an initiator. In this case, we substituted ammonium persulfate for hydrogen peroxide and ascorbic acid. What we achieved was, firstly, for the carbon footprint improvement, we were able to drop the reaction temperature from 85 to from 40 to 60 degrees Celsius, which of course lowers our carbon footprint in the production. It lowers our heating costs, our production costs, and on the other hand, it also achieves higher molecular weight, which usually means a better performance of our coating. The last step, which was already implemented in our production, is the use of hydrogen peroxide in wastewater treatment. So a lot of our liquid coatings, liquid polymers are polyester based, which means we have a lot of processed water that is generated in the polycondensation polymerization reactions. This water is usually contaminated with some glycols, which have to be treated for it to be released back into the environment or to the water treatment plant. This is being done used with UV and peroxide oxidation. Our yearly need is about 120 tons, calculated for 2024. Of 35% hydrogen peroxide. So this was the easiest way we could implement hydrogen peroxide into our production. We also tried two different pathways according to our agreement and what we promised. And we are quite successful in the implementation. And if there are any questions, this is more of a general introduction to what we've been doing.
Thank you very much, David, for the contribution. So I don't see any questions. And thank you, first of all, to all presenters also for being in time with the presentations and for all of you to be here, of course. Now, before moving to the panel discussion, we have actually a new contribution. That's why also the interruption of before. And say yes. So please welcome on stage Andrei Podgoritnik from Belinka Petrochemia. He is head of research and development, and he will give us an overview of how Hyper will progress until higher TRLs. Thank you, Andrei.
Thank you, Marco. Thank you to everyone. Maybe quick introduction about just what Marco said and Richard at the beginning. So the idea of this presentation is to present to you how Belinca Perchemia fits into this project, fits into this process, and of course also to maybe present to you our opinion how potentially the project can go into the further steps from Tier 6 and beyond. But first of all, to little bit say about Belinca Perchemia so that you have understanding the next step where we talk about the role of Belinca Perchemia. So what is important is that we have quite a big and long history. We started in 1948. What is also very important is that we are one of the 7 European producers of hydrogen peroxide in so we are also part of the peroxygen group in the Pacific. And our technologies that my colleagues before me presented the attendees process and what is maybe a little bit different from other producers and other sites of producers of hydrogen peroxide. We have our own steam methane reforming production of hydrogen on site. So we have our own hydrogen production on site. Maybe in some other areas they don't have it, and they bought and bring the hydrogen to the to the site from via transfer through pipeline. This is actually what is important. Wanted to say is that we have all the necessary experience that is the production of hydrogen peroxide, knowing the product, knowing the specialties, and this is something about our portfolio. We are really focusing on specialty grades of hydrogen peroxide, focusing on products that are the end of with using hydrogen peroxide, so peracetic acid. We are one of the largest, and I can probably say the biggest producers of sodium perborate in the world. And we also going now into the direction to bring products of hydrogen peroxide into products with added value such as detergents to really tackle all the necessary segments and areas and industries where this kind of products can be used. So all this introduction comes to the role of Belinca Perchemia in hyper process. At the beginning, I said that we started in 1948. The technology that we used at that time, so in the 50s and to the 70s, we use pitch Adolf process, which is predecessor to the technology of hyper. This is also very interesting. Of course, the hyper is now modernized, sustainable. You saw great presentation from Airstank just before how great and promising LCAs regarding to anthracene process. On the other hand, we really are bringing expertise of using and managing and potential business models for this process in the next steps. So hydrogen peroxide production expertise, extensive expertise in hydrogen management. Also, our facilities are part of the ATEX requirements, and we have also strong safety culture. And what is the next step? I'm proud to say that colleagues from the consortium, JSI Chemical Institute, EUT, Condias, really brought the technology to the step that we are now in, that we are going to Belinca Perchemia and to demonstrate and start demonstrating the pilot plant in Belinca. So from the concept to the tier 4 and 5 in Inotex that was presented to us with a great passion, and in the second now coming to Belinca Perchemia in a little bit different way and a little bit bigger. So this is the site of the demonstration at Belinca Perchemia. What we provide is the demonstration site This is in our company next to boiler site and also hydrogen plant. We will install it on site. We will give all the necessary connections for the plant, and we will operate the process with 5 campaigns for 200 hours, what is actually our goal of the project. What is very important is also to analyze the whole system and see what actually the process will bring at the end, and see what kind of product the 06 technology will give. So looking forward beyond 06, based on what my colleagues said before me, we have really solid fundamentals at this point. The project has solid fundamentals on techno-economic analysis that Hank from PDC presented, also LCA, and the project should really not stay in some drawer and should really bring the right partners to the next step, search for new funding and bring technology to the end users. That was presented before. Regarding the quality, one of our partners, Inotex, did some preliminary tests, and it clearly shows that the hydrogen peroxide is pure, so potentially no need for another step of purification would be needed. So this could open really potentially segments of added value in the future to tackle this kind of, so that we discussed it before, the dependence of the price of electricity and potentially difference in the European market. You know, it's how it's in Italy, you know, it's how it's in Slovenia, maybe in Austria, and on the next step to the Norway, which the prices really are quite different. So when you're talking about the industries such as pharma, such as electronic wafers and etching, where hydrogen peroxide is used, the price is never a question. And that is really a great opportunity where you have potentially such a good quality of the hydrogen peroxide. And yeah, thank you very much for your attention. Please.
Thank you very much, Andrei. If there are any questions from the audience?
One of the things we talked about is that Hyper is very modular, right? So when we talk about the exploitation, we still have the same model that hydrogen peroxide is produced in a central location, or does this also really bring us to new business models? And do you have any ideas of what the different business models could be?
Thank you very much. Very great question. Regarding the business model, I believe that till the end of the year, we will prepare as a consortium really all the necessary routes where actually would be the best tackling way to be going ahead. This is just my presentation, my opinion. Of course, the consortium potentially has other opinions, but of course, I believe that even in modular that we presented with the proposal could be a great solution for the industries that we have here, that was presented here. Because, of course, when you go in higher scales, higher production, 300 tons per day and so on, the cost, of course, decreases. But when you're talking about the products with added value, even with lower quantity, you can achieve a great business model.
Thank you very much. So now we are on time. I would say before the panel session, we can have a really short break so that we can arrange the room also. So 5 minutes break. Do not leave the place. So welcome back, everybody. Now we move forward to the panel discussion with some of the partners of the IPER project. The goal of the discussion is to explore a key question: how do we effectively bridge the gap between innovation and industrial application? And so let me introduce to you the panelists. You've already met Richard, Andrei, and Ank. We also have for the panel discussion Martin Ocepek, Director of Research and Development at Alios Resins. So first of all, are there in general any questions from the audience? Questions do you want to ask? Otherwise, I also have some questions. Okay, so this is an opening question for all of you, so feel free to answer. In your view, what is currently the main barrier to scaling up the IPER technology to industrial level? Richard? The time for answering? Oh.
I know that I've been in contact with some industries. They want the solution. Should you use the microphone? I've talked to some industries, and they would like to have the solution yesterday. And it takes time to develop. Even as Andre said, this is really based on technology which was first developed a century ago. We're making it new, we're making it better, and it takes time to do it. And you have to make sure that you don't skip steps.
Yeah, the advantage of Hyper is that the process for scaling up is different because we can produce modular processes that can be applied for small applications already. I think sooner than for the bigger ones, although you can also develop very big and efficient plants with it. So you have multiple options, whereas if you would compete directly with the existing hydrogen peroxide business, you're looking into production units that are at nowadays around 100,000 tons per year, 50 to 100,000 tons. And that is not necessarily needed to go that far for a first application. So I think there we have some benefit. And within the consortium, we're also looking, and we will have an exploitation workshop this afternoon, to see how we take the next steps to go beyond TRL6 and have the first industrial application.
Thank you for answering. Then next question. Do you think reaching TRL6 is enough to attract industrial investment? And how do we, is there still a critical gap to attract industrial investment?
I don't know if I want to answer that question.
It's too personal. Okay, thank you.
With the process really achieving tier 6, that I don't have any doubts that we will, because I saw the technology that Gregor presented a few weeks ago and was really working great. The transfer to Belinka and to really prepare it, I don't have any doubts that operation will not be successful, so it really be successful. But regarding to the industry and to bringing the funds from the industry, I believe that this can be achieved. Of course, there are partners, industries that will welcome such a technology because in certain areas, of course, you have to understand business of hydrogen peroxide as a technical commodity, technical grade. There is not much of a business, because at the moment there is a bloodbath on the market, because the prices are so low that even the producers don't have any margins regarding technical grade. But you have to understand that on the other hand, for other uses, the prices are just going up. And this could be a really good focus, and the industry could really come after the tier 6 presentation and demo. On the other hand, Richard already talked to certain industry partners that are, as he was mentioning, ready now, or why is not already developed, and so on. These are the questions, the right questions that the industry are asking, because those industries have a lot of funds.
I mean, I think everyone is interested in this green transition, but new technologies like hyper are fighting a price battle, because there's a competitive advantage for all of the fossil-based processes which currently exist. They've been developed to the nth degree over decades, and you have governments providing fossil fuel subsidies, and if governments really want to see this green transition, then I think you need to see the policies change in order to, I don't want to say subsidize, because you don't want to build a business model based on subsidies, but to at least remove some of the competitive barriers that these green transitions have with respect to fossil fuel technologies.
Thank you for the answer. If in the audience there are like experiences on these, if you want to share some remarks on these, feel free to raise your hand. Otherwise, we can move to the next question. So this is very general. In real industrial decision making, what weighs more today, economic competitiveness or environmental performance? Because there is always a balance between sustainability and cost. If any of you...
Yeah, it's of course very, very difficult question and very good question, because at the end the business, if you look generally at the business, you have to have growth, you have to have positive EBITDA at the end of the year, and the investors are looking for the business model that is beneficial for them. This is the first thing that I would like to emphasize. On the other hand, European Union is really going into the direction, and we are going to the direction, as Richard emphasized before, for the green transition, for the Green Deal and to lowering our impact on this planet. And without going into direction and searching for the technologies that could bring this better future for our children, yeah, this will not be possible. So there has to be balance, of course, and as Richard mentioned, there must be subsidies for these kinds of technologies so that the industry will really become interested and invest in this kind of technologies.
And maybe I could add, from our perspective, we are consultants for the industry, of course, and we have different clients from small to big. But we see, whereas in the past, all our work was driven by cost as a main objective function. Nowadays, you see also other elements popping in. And even today from the consumer market, so end user producers that ask us to help them to improve the carbon footprint of their suppliers, their raw material suppliers, and which ones to choose and what decisions to make. And of course, there are a lot of databases that consultants use, but the actual knowledge of how to produce in a more sustainable way and also use that in the consumer market is something that some brands really look forward to. Even if it's a little bit more expensive, of course it should not be too expensive, they can afford that, because it doesn't really matter if a bottle of a perfume is 1 cent or 2 cents in terms of material for construction. That doesn't really matter that much. But if you can prove that it is made out of total renewable material, you have an extra leverage to your customers saying, hey, look, we are a sustainable company. And that is, I think, if the consumers really go for that, they show that they want that. Of course, they don't want to pay much extra. That the bonus for green is often very low. That is a given. But if you do it smartly, and we show with Hyper that we are in a good way, also in terms of economics, we can do it together. Both have a lower environmental impact, be more sustainable, and also produce it for not much more expensive. Because often people say, yeah, but sustainability is expensive, you pay 3 times more. That's not the case. The differences are relatively small, and I think we can come there, especially if you have a lot of convenience in producing your own hydrogen peroxide. You do not need storage, you do not need stabilizers that you maybe need to remove or have difficulties with in your product. So there are a lot of benefits that you can also stress beside only the economic part.
Maybe I elaborate from that. So thank you for opening that up. So we are a material engineers, so I won't comment the process engineers because we have a lot of experts around me and even among other partners. So being one step further in the value chain, so downstream user of hydrogen peroxide, we aim towards to use a hydrogen peroxide to replace some of the classical compounds which are more harmful. And there was a good example before showed by David. So using hydrogen peroxide as a partial oxidizing agent of vegetable and other oils to produce oxyrain ring on different kinds of molecules. That is a much more sustainable solution to replace traditional epoxy resins, which you might know that is based on one hand bisphenol A. You don't want that to handle, right? On the other side, epichlorhydrin, very reactive one. We had a big accident just a few years ago in Slovenia. A lot of people died, unfortunately. And this is a new approach. So new approach, it's a new material. Of course, price is always a challenge. Also in the resin, in coating industry, we also produce composites. But maybe it's a little more gap than with the commodity hydrogen peroxide, which Belinka is struggling, our sister company Belinka is struggling at the moment. But yeah, the focus should be in the usage with a higher added value when the premium price is a little bit easier accepted by the market. Although we know the whole European chemical industry is in a big challenge now. There were several primary compound productions shut down in the recent years, from phthalic acid anhydride for on. And yeah, that's so the green chemistry, not just the hydrogen peroxide itself, but building up from that to the novel materials that could be a trigger or a breaking point to introduce that technology to economical level.
Thank you very much for the remarks. If you have any comments from the audience on this, otherwise I also ask another question. We've seen an application in coatings industry for production, so in industrial application. Which are the main challenges to bring the pilot plant to an industrial level and market level? If you know.
I mean, in the project, one of the challenges has been, you know, if you need to run this with renewable electricity, the availability of that renewable electricity, the inconsistency of that renewable electricity, the size of the different applications, and how do you know, put this puzzle together is a real challenge.
I mean, as presented already within the Hyper, we have 3 different companies which very different applications. So in most cases, hydrogen peroxide is used, that's simple, but as an oxidizing agent to oxidize the compounds which, yeah, discolorate the products. So bleaching process for different kind of cellulose or other carbohydrates, just to make things whiter. That's the main application. But we try to show also with our case that also it's possible to use it as a precursor to some more valuable compounds, and that's definitely the path we pursue. But yeah, so implementing then the modular unit in these facilities has totally different aspects. I think in Andritz technology, when the whole paper mill is produced, they have experience also to maybe not so, it wouldn't be so difficult to install another unit to their plant and to make control. They have the knowledge and resources and the safety consideration, everything is included. But maybe if, yeah, in the textile industry, in the coating industry, that's not the chemistry we would do every day. I mean, we don't operate with hydrogen on a daily basis. So it's a lot of precaution, a lot of measures, a lot of permissions that we would need to get. That's a big hurdle, especially in Europe. I mean, especially in Slovenia, I would say also. But it's sometimes impossible to get the permission for such devices on some sites. Yeah. So it's some investments, also investment in educating people and so on. So probably at the end, kind of hybrid. So we need centralized production to supply the majority of the market, and for the big consumers, maybe modular units are more appropriate.
Yeah. Maybe I can add one thing. Now we have a unit out of glass, which is very nice because you can see what's happening and it's quite resistant to the materials. But at larger scale and in industry, of course, you need something made out of different materials of construction. And yeah, that is the next challenge, how we will do that, how we will scale up those units, what materials will be used, and how to more or less fabricate these kind of modular systems. And then it's still the question how you scale up. Is it just modules next to each other? I see that more and more happening. And if you do that, you could say you lose economies of scale. But on the other hand, we also know that if you build row houses, so a street full of the same houses, it's far cheaper than if you build every single house individually. So there are some benefits that you can have from that as well. And that is the challenge that we are now facing in the next step, how to deal with that. So we'll discuss that also this afternoon, I expect. So, but I look forward to that next phase.
Thank you very much for the very interesting insights. And I believe this is a very broad discussion because it's in general about bringing research to industrial application. So we're approaching the closing of our workshop because it's almost midday. And I asked the audience if there are any other remarks, comments, questions. Otherwise, we can close then the session, and there will be a light lunch buffet for everyone outside here for networking and for other comments you may have, personal comments. So, okay. I don't see any other, okay, one question.
Vince from Process Design Center, colleague of Hank Fleming. I was wondering, for the next stage of the hyper unit, is also an incentive from the policymakers helping to push this technology further? Or is it more from an investor point of view that should be helping in this case?
And I'm answering this question with the hat that I have because I'm involved in Processes for Planet, which is a partnership with the Commission and the European process industries. You're going to see a lot more push from the Commission in terms of bridging the gap between, say, TRL 6, 7 pilots and TRL 8 and 9 pilots. And you are going to see new instruments that will allow that to happen, and there's going to be more money involved. In a lot of respects, you know, some of the member states are a bit of a break on this because, you know, they don't see maybe the benefit of using public money to go to, say, TRL 8 level investments, because I think maybe they consider that to be too industrial. I don't know the reason. But in the next framework program, you're going to see a lot more money and more money dedicated toward these higher TRL projects. And the Clean Industrial Deal, which has a deadline in September and then another one in 2027, is a precursor to what you will see in the next framework program.
Thank you very much for the question and the answer, Richard. So at this point, I would conclude the workshop, because I don't see any other questions from the audience. And thank you everybody for joining and for the active participation.